All right, welcome to the eighth part in the Trippy Nature tutorial series. In this one, I'm going to be talking about how I made this blooming flower animation for this couple of shots here. Um, so as I was going through my hip file that I made over a year ago to try to make this tutorial, I realized that it's a total piece of garbage and that I should never show anybody how I did it that way. When I made the nature video, it's been over a year and a half since I made that, and I didn't really know what I was doing in Houdini. I did it like the least procedural way possible. So I hand modeled every single petal individually and hand placed them all, and then put bend deformers on all of them, and then keyframed the bend deformers so that they kind of closed one at a time, and then ran it through a Vellum sim, and it worked. It was fine. It got me what you see here, but it really only worked from like that angle. It wasn't perfect. It's not great. It wasn't really very reusable or procedural. So it was fine for at the time, but for this tutorial, I did a bunch of R&D on my own in the last couple of weeks and really just dug into like how to build flowers so that I can give you guys a much more concise and way more procedural and easy to understand tutorial. And I don't know if you've noticed, but there isn't really a whole lot of information out there on tutorials on like how to make procedural flowers in Houdini. And the few that I've been able to find are really complicated. You see these amazing blooming animations and they just look so effortless, but then once you actually see how it's done, you're just like, fuck my life. It's all Vex, it's all code, which is fine. That's how you get a lot of control with that. But I wanted to try to simplify it and do it with MOPs and buttons and sliders and using minimal Vex to just make it as easy as possible for myself to understand and also for you guys to understand. So I'm going to show you the method that I came up with here. So to get started, let's start by modeling a petal. So let's put down a geo and we'll just call this flower. I call it flower simple because it's going to be pretty easy. Okay, and let's put down a curve, and we're just going to draw out the profile of our flower. So if I hit spacebar 3 on the keyboard, it takes me into this front view here, and I can kind of line up the 0. And then let's turn on grid snapping and hit enter. So that'll bring up my curve tool here. And let's just start by drawing out something like, I don't know, go like this. Something like that, and then hit escape. I'm done. Okay, so then I can come back here and I can adjust this. So you can kind of, it gives you little tool tips here. If I hit F, I can, brings up my little menu here. I can hit middle mouse to kind of drag things, middle mouse to drag things around. I can also, I think, control click to use the, turn it into like a smooth Bezier curve. So that's what I want to do, is turn these all into nice Bezier curves. Something like that. Just kind of mess around, and I made this flower up. This isn't based on anything. I just kind of made this kind of long pointy petal one, but if you want to look at, you can just type in flower petals or a specific flower, and you can kind of look at what a single petal looks like and then model it based off of that. Cool. So let me get something. Just kind of play around to get it. It doesn't have to be super perfect. We can always adjust it later. But something like that seems decent. Maybe a little more of like a, yeah, cool. Okay, then I'm going to mirror it so that it goes across the x-axis here, or across the z-axis. And then I still have points like that. I want to resample it. Okay, let's turn this on so I can kind of see. Let's go subdivision curves. Let's get it like something like that. Okay, and then I want to fuse it so that they fuse together so that they're not separate polygons. turn off this, turn on my polygon line. Now you see I still, if I turn on this polygon thing, I can see I have 0 and 1. There's still 2 polygons even though I fused it. So if we use a poly path, I think that's what it's for. Yep, now it just makes it 1, so we just have 0 up here. It just makes it one single path. That's what I want. Okay, so I've got my profile shape, and at any time I can come back here and adjust it. So what I like to do is I'll highlight the curve, hit C on the keyboard and make it pink so that I know that this is something I can adjust. So I can just come back here at any time and just mess around, and it does it on both sides. Cool. All right, the next thing I want to do is do planar patch. Oops, not planar patch from curves. This one. What that does is it just kind of fills in the gap with a bunch of triangles. And it's nice to have triangles like that because we're eventually going to run this through a Vellum sim, and that Vellum tends to like triangles a little bit more, I think. Nice even ones. So let's bring this down to 0.02. Maybe that's too much. Maybe let's do 0.05 for now. We can always up-res that a little bit later. Let me save this as, in case this crashes, tutorial live. I'll save it. Yeah, that's fine. Okay, great. Then we need to make sure we put some UVs on it. So UV project, and that just gives me a nice flat plane. Let me hit Shift W to get rid of those triangles. If I hit Shift W, I can bring it back on, but I want to see this a little better. And then here I can kind of scale it. Let's go 2. Yeah, there. So that way, I always forget to do UVs, and then I always have to go back and do them. So I just like to put them on there at the beginning. Okay, then we're going to need a start group and an end group. And I'll explain that a little bit later, why we're going to do that. But for now, we're just going to make it. So I want the start group to be this bottom point, and I want the end group to be the top middle point here. And so a great way to do that is to go sort. And so if we pull up the point numbers here, oops, the point numbers, you can see they're all, like there's 0 here, there's 690 there. I think they're kind of all weird. 682, I don't know, maybe they're in the right order already, but let's just do this. I can sort these so that if I go point sort by Y, now they'll go in numerical order, 0 being the lowest and 757 is the top. So that's what I want. I want the highest point at the top and the lowest point at the bottom. Okay, and then I can do a group by range, and we'll call this one start. And what I want to do is I want to make sure this is a point group, and then let's go like this. So you see how this one disappears right here? Let's just move it up 1 and it disappears, then hit invert range and it'll select only that one. Great. Now let's do the same thing here, but we're going to call this end and make it end. And we're going to do the opposite thing. So we're going to go like this, right? Makes the top one disappear, and then hit invert range, and then we have the top one. Great. Done. Okay. The next thing I want to do is I want to make some noise. So let's put a point VOP, and let's make this pink because it's going to be something we can come back and adjust later, and we'll call it noise. And what? Why did it just do that? I didn't put any noise in here. That's so strange. It must be a viewport. Weird. I wonder if I call it something else. So wait, if I just call this noise, it just does that? Man, that's weird. Okay, I have no idea why I did that. It should not have done that. Must be some glitch. I probably need to restart my computer at some point. I've been using it for a lot. So anyway, let's dive inside. Let's put down a turbulent noise, and let's put an add, and we're going to add this. Just wire it up. Oops, shit. Position to position, and then that goes there, and then we're going to put that to the new position. Okay, cool, but that's like I think this is a 1D noise. That's why it's kind of all going in this one direction. We want a 3D noise, right? And let's do something more like zero-centered purlin. And we can adjust this, make the frequency higher or lower. I'm just going to do kind of a low-ish frequency, maybe a higher amplitude, something like that. Okay. Now, one other thing is I don't want noise all over this whole thing, right? I kind of want it to be noise-free at the bottom and then get noisier towards the tip. So what we can do is we can create a ramp based on the Y position. So if we take our position and we go vector to float, that splits it into its 3 X, Y, and Z components. And we want the Y component, and we don't want to make a ramp parameter. And then we want to, before this noise gets to the add, we want to multiply it with this ramp. And let's make sure we turn this to spline ramp. So let's go mult and plug this here and that there. And then it's going to make everything go back to 0. But if we go up one level, the ramp is here. And if I put one end up, you'll see I have control over where that noise is, right? Now I wonder, it's weird, it seems like it's not going all the way to the top. And it must be interesting. Must be because this is 0 to 1. Maybe I can remap this. Let's go fit range. I think it's because if we go out, I'm guessing here, spacebar 3, this is 0 to 1, and this goes up to 2. So it's not giving me that full range. I'm guessing it's because this spline ramp is 0 to 1. So let's try feeding this ramp through the fit range, 0 to 1, and go 0 to 2, and see if that makes a difference. If not, I may have to. Huh, interesting. Well, I'm not sure why that is. Okay, so I think I figured it out here. So I want to go, so it is in fact messing up my noise because this petal is going higher than 1. So what I need to do is do a fit range, and I need to do it before the ramp. And my value coming from here, my height is 2, right? So the source is 2, but I want to fit it to between 0 and 1. So now when I come out here, I have this slider, and you can see it goes all the way down to the bottom and all the way up to the top. Great, that's what I want. So I want to be able to have some control, and I can, crunch this in. Let's grab both of these, make it like monotone cubic. Give myself a nice little fall off here. And the other thing I want to do is come down here, right click, go Vex Vops options, and do create input parameters. And that just automatically promotes all of these things to the top so that I have some nice control here. Let's turn off that. Let's turn off that so I can see better. So I have some nice control. I can, switch the noise, switch whatever, alligator, simplex. Let's do simplex maybe. I don't know, maybe zero-centered purlin. Can change the amplitude here. We can always adjust this later, but I think, I want this bottom part to be relatively untouched. And then I want the noise to really become stronger towards the top. So maybe, I don't know, just a little bit, and I can adjust the frequency. Try not to get too many intersections, or really any intersections if possible. But we can adjust this a little later. I'm just going to dial it back, maybe lower the frequency. Like that. Let's see what that does. Okay, just a little bit of noise. That's fine. Okay. So the next thing I want to do is I want to create a distance along geometry. So distance along geometry. And I want to output a mask, but I need to give it a start point. So I'm going to use my start point that I set up already. And let's visualize the mask. So if I click mask, you can see what it's doing, right? So it gives me a nice fall off here that I can control. Again, I don't know why this isn't going all the way up. It's so strange. You know? Okay, so this doesn't seem to be going up all the way, and I think I know exactly what the problem is, and it's actually I should have known this. It's what's affecting my noise too. So since we have built this petal shape in the 0 to 2 range, it's kind of messing up everything. So that's good to know. Try to build things in the 0 to 1 range. So all I'm going to do is after this UV project, I'm going to put down a transform, and I'm going to reduce the height down to 0.5 so that it just stays in the 0 to 1 range. So in the future, I probably would just build the curve from the 0 to 1 range. Okay. So then the sort should still be the same. We should still have the same start group, right? Yep, there it is. Still have the same end group. And then this noise, we probably no longer need this fit range anymore. I can just take that out. And it should be going from the bottom to the top. Yeah, it's working way better. Okay, and then the distance along geometry, when I move this, it should go all the way to the top. Great, okay. So that fixed all my problems. Sorry about that. But now you know the solution to that. Okay, so this distance along geometry, I actually want to reverse it so that I have the red part at the top and 0 at the bottom. And so I'm outputting an attribute called mask that you can see there. And what we're going to do with that is we're going to use a bend. And let me turn on the bend, hit enter so I can see it, and G on the keyboard to bring up the little gizmo thing. And this is bending the wrong way, so I want it to go this way and this way. I want to bend it, let's bring this in, I want it to bend the side in, and I want to go deform in both directions, and I want to not limit the deformation to capture region. So let's go like, let's bend it like far so we can really see what we're doing. Just something like that. And then one thing that's really cool is you can use this mask here. You can turn mask on, and instead of bend attribute, let's just change it to the mask that we just had. So now, with this distance along geometry, I can use this ramp to control where the bend is. And I don't want the whole thing to be bent. I just kind of want the top part to be bent in a bit. You see how that works? So now I have control over kind of shaping my petal a bit. And maybe this is probably too strong of a bend. I just wanted to do that so you could see what's happening. Something like that. Cool. Okay, great. And we also have this mask attribute, 0 to 1, which we can later on use in Redshift for shading this flower. We can make, the tip could be lighter or darker than the bottom or something like that. Okay. The next thing I want to do, just for shading purposes, is another distance along geometry. Distance along geometry, and this time I want it to go from the middle out, and this will be for shading it later. And so I need to create a middle group. So let's just put down a group node. I'm just going to do this kind of hacky. I'm going to call it middle or middle with an E. Make sure it's a point group, and then let's do keep inbounding regions. Let's go bounding sphere. Let's bring this up to 0.5, and then let's shrink it a bunch so it's just like some points in the middle. Let's try and just get like a couple points, maybe just that one right there. Okay, so we've got the middle group, and then distance along geometry, the start point will be middle, and let's put an attribute called mask2. Let's call it middle mask. Great. So now we have this mask that goes from the center out. We're not really going to use that for anything right now, but for shading later on, it'll be helpful to have. You can make the center be lighter than the outside or something like that. Cool. So we'll just leave that for now. Great. Okay, let's add some normals. Oops, normal. Cool. Looking good. All right, and then we can add a smooth if we want. Like right now it's pretty smooth, but if your noise, if you went in here and you made it like really jaggedy, something too jagged, I don't know, you could use a smooth to smooth it out, but I think ours is fine the way it is for now. I'm just kind of showing you the basics. and then we can adjust this later. Okay, and then the last thing here, let's add in another bend. And I want it, hit G on the keyboard, rotate it. By the way, if you hold Control while you rotate, it snaps it to 45-degree angles. It's kind of nice. And I want this to be kind of back like that, I think. So maybe back, and let's bring it maybe like up, maybe shorten this a bit. Just, sure, something like that would be fine for now. We can always adjust it. Okay, and then let's go put a null down, and we'll put out petal. I like to color those black so that I can see them. And then we can just take this whole deal, put it inside a net box. Let's call this petal shape, and then make it green or something. Okay, cool. So now we have the petal. Now we need to arrange it in the way that we want it to look. So I'm going to use the MOPs, and again, if you've seen my last tutorials, I like to use MOPs. It's free plugin, motionoperators.com. It's awesome. It just allows you to do things like if you come from Cinema 4D and you have all the MoGraph tools like typography and all the fall offs and fields and stuff like that, it's going to be pretty comparable to that. And of course you can do all of that stuff in Houdini without MOPs, but I just prefer to use MOPs because it's, I don't know, it's more friendly looking. There's not a lot of, you don't have to use Vex. You can just make what you want and have buttons and sliders, and it's great. So I'm going to use the MOPs instancer. So just plug this into MOPs instancer. Okay, and instead of a grid, I want it to be linear, and I want this facing upwards. So I want to clone them up like that. Okay, I also noticed that these are flipped around. I want them facing the other way. So if I go to instancing, global transform, I can rotate these. Now I want it. How do I want to do it? Is that it? Yes. So let's go 180. That's correct. Okay. And then distribution, great. Okay. So then what I want to do is I want to be able to rotate these around in what's called a phyllotaxis, which is basically how the mathematical term for like how things are arranged in nature. And so what I want to do is do a MOPs transform, and I want to ideally rotate these around the center. Why is this not doing it the way I want? Oh, that's weird. Oh, you know what? One other thing I forgot. So this bend here, that's all cool, but this is facing the wrong direction. If you want cloners and instancers and stuff, they expect the top or the leading edge of whatever you're putting into to be facing in the Z positive direction. Right now it's facing in the Y positive. So let's put down a transform. And let's just bop 90 like that. And that should be fine. If I go back here, I probably don't need this anymore. Yeah, I think that's correct. Okay, that seems, or actually I want to, it's almost correct. I think that's right. May just have to play around with it to get it the way you want it. Okay, so this MOPs transform modifier is going to rotate everything around, but it's doing them all uniformly right now, and I don't want them. I want them to rotate around exponentially more as it gets higher. So MOPs has this great fall off called MOPs fall off from attribute. And what that does, but it defaults to using ID as the attribute. And so if I preview, you can see it basically gives a unique fall off to each one of these clones. So the blue meaning nothing's happening, white meaning the full effect is happening. And it outputs this fall off attribute called MOPs fall off, which then gets fed into here. You can see if I click, a do fall off is on by default, but if I turn it off, you can negate that, but it's on by default. And now if I rotate this, you should see it's rotating the one at the top a lot more, and it's rotating the one at the bottom not at all, and everything in between. Pretty nice, right? Now I want this to be kind of how it is in nature, and so what you do is there's this magic number that's 137.5. That's all you need to remember. It's 137.5, and you multiply it times the amount of clones you have. So I think I have 10, so let's put 10, and it should arrange it in the way that it would be in nature. Now I want to make this procedural, so I don't want to have to type in 10 every time. So let's come to the instancer. Let's go to distribution. Let's copy this parameter, the number of points. Let's come back in here, delete that, and paste relative references. So now whenever I change this, it should, oh shit, it goes a lot. Should just arrange them the way I want. So let's put like 13. Cool. And you can kind of see I have the length of the line set really high, but they'll look a little bit more like that. So I'm leaving this length high so that I can leave them kind of spaced out like this, so that they're not intersecting. And I'll show you why in a moment. But when we feed this into Vellum, you can't have things start out intersecting, or else it just won't work. So I have to find a way to start with my flower non-intersecting, and then use Vellum to bring them all together in the shape of my flower. Okay, cool. So let's call this one Phyllotaxis. So we know that that's the one that's arranging everything. Okay, and let's see. So basically what I want to do is I want to animate these downwards over time. So let's start doing that. So let's take this length. Let's do that here. Let's go to like frame 72 and bring this down to 0.01, something like that, so that over time they animate on top of one another. Okay. I also want to animate them upwards a little bit. So let's go back to this Phyllotaxis here. Let's take this rotate and let's, oops, why is this not working? Strange. Wasn't letting me scroll left for some reason, so I just have to type it in. But I want these to rotate, kind of angle themselves upwards a bit as it comes down. So let's go like -70, -90. So the ones at the top are kind of facing upwards, and the ones at the bottom are facing down. Maybe 90 is too much. Let's go like -80, something like that. And let's keyframe that at 72. And then over here, let's bring it back down to 0. So again, we're starting non-intersected, and they're all kind of the same. And then as it animates down, they all kind of go into the shape that we want it to. Now I think this is still a little too spaced apart. I kind of want these bottom ones to come up a little more too, so we can do that. What we can do is we can put down another MOPs transform, and we can affect that. So if we just come to this rotate here, we can do the same. It's basically doing the same thing, but again, it's using this MOPs fall off we already have, so it's kind of not working the way we want it to. So what we need to do is remap this fall off so that it only selects the ones we want. So we can use a MOPs remap fall off. Put that down here, and let's look at it here. Let's do preview fall off, and right now it's the same, but we have this ramp where we can kind of select things. So again, blue is nothing, white is everything. So I want to invert this so that I'm selecting the ones at the bottom and not the ones at the top. And let's bring this down so that I don't really mess with anything at the top, but I mess with the bottom. And again, this is outputting MOPs fall off. So I had a MOPs fall off already up here, doing this right here, if I just leave this at MOPs fall off, it's just going to overwrite what I already had, and that's fine. So now this here should only affect these bottom ones that have a color that's not blue. So there we go, right? So let's do something like, I don't know, minus 26, bring them up a little more, and then we can, of course, adjust this fall off here. We can just kind of use these sliders or this ramp to kind of figure out something like that, kind of get it into position. There, that's starting to look more like a flower. A simple one anyway. Okay, so let's, again, we have to, if we start this way, they're intersecting. We can't have things start intersecting. So let's come to this MOPs transform, and let's go to frame 72. And we'll put a keyframe for where we rotated it, and we'll come back to 1 and change it to 0. There. So again, see no intersections, and then over 72 frames, it sort of animates into place. Cool. And I can also use the phyllotaxis here. Maybe this one, I can use this to scale down things. So I can use this to scale down the middle if I wanted, have the ones in the middle be smaller. So maybe I'll do that. So maybe let's have start at 1, start on frame 0 or frame 1, uniform scale of 1, and then come to frame 72. And let's just kind of do this just a little bit smaller like that. So it feels a little more natural. Okay. Great, so we've got our flower animating into position. Let's, what we need to do, these are all packed primitives right now, so in order for this to work in Vellum, we have to unpack. And now we have all of our attributes back, and our points, see 9,000 points, whereas before it was 13 points, 1 for each clone. Okay, so let's take these guys, put them in another net box. And we'll call this phyllotaxis. So we know that's kind of, we're using that to position. So we've using this here to create the petal. This here is kind of getting it all into position. Okay, now we need to de-intersect these. So right now they're animating into position, but there's, I don't know if you can see very well, there's some intersections in there, and we can't really have intersections like that in Vellum. In order for it to work properly. So what we're going to do is run this through a Vellum simulation. So we'll do Vellum cloth, and we want a Vellum solver, right? And I'm just going to call this cloth one, cloth start, so I can find it easier in a sec. I'll show you why. So in the Vellum solver, let's make sure that we turn off gravity. And I think the one thing I want to do, I want to make sure I pin the start point. So remember the start group is that little point right at the middle. So let's come into our constraints here, or our cloth constraint, and find pin to animation. And let's pin the start group, and let's go soft and match animation. So now if we just play this, it's just all it's going to do is pull down the center. It's not really what I want. It's kind of what I want, but not really. I want it to be end up looking like this, and it's not really doing that. So as I was playing around, I found out that we can use the Vellum rest blend. And it's really cool. I'll show you that in a sec. But first we need to pin these. So let's go, we need a Vellum constraint. Let's put that in here. We'll call this pin. And we want to change this to pin to target. And what we want to do in this is we want to pin every single point in this whole thing. So all we have to do is points and just put a star, and that will automatically pin everything. And then the pin type, I want it to be soft, and I want to match animation. So what that's basically going to do, it's going to take this animated geo that we made, and it's going to try and pin it to itself, and through Vellum pull it into that exact position, right? Does that make sense? And I found that using soft, a pin type of soft, seems to work better than permanent. So if you see these constraints here, all the constraints are literally just lines. And imagine them a permanent constraint. Imagine that each of those lines is like an iron bar. They're unmovable, and it's going to do everything it can to pull these petals to the position that you want it to. And I found that when doing it with a permanent one, it pulls so hard that it pulls the petals through each other, and you get all these crappy looking intersections. Whereas if you use a soft, if you just imagine each of these lines is like a loose rubber band, and you're just kind of pulling on the rubber band, gently guiding it into position. And as the petals collide, the constraints aren't really strong enough to pull them through one another. It just kind of pulls them into position naturally, which is nice. And I played around with some values. The reason I like using this pin constraint here versus just pinning everything up here, because we could just put a star here and do essentially the same thing, but I don't want. But you don't have any control over how strong the constraint itself is there. So let's put that back to start. Over here, you have these parameters here that allow you to control how strong these constraints are. So I want them to be pretty weak, actually. I want them to be kind of loose so that they don't really pull themselves. Like I said, I don't want them to be so strong that they pull the petals through each other. So let's bring this stretch stiffness one down to 0.0001. Let's bring up the damping ratio a little bit, just make it kind of dampen some of the energy, gets rid of some of the jitteriness. And then for the bend stiffness, I want the exact same thing, 0.0001, 3 zeros and a 1, right? Okay, so cool. Now, let me show you what that does. So if I put this, actually, yeah, let's just run this really quick. So it's working, it's pulling them all into position, but you know, if you noticed, I shrunk some of the leaves in the middle. It kind of sometimes, I mean, that's actually worked pretty well. Sometimes you get some really strange behavior when you're trying to, like, see how up here I'm shrinking the leaves, like they start. The ones that are shrinking the petals, so the ones at the top here, they start full size and then they kind of get smaller over time. Sometimes when you do that with Vellum, especially if the size change is really dramatic, you get some strange behavior and you get intersections and things start to collide, and it's not great. So this one seems to be working pretty well, actually, but in my previous tests, it really wasn't working at all, and so I had to use the Vellum rest blend. And if you're unfamiliar with, see, look at that, that's pretty good. It's pulling it all into position. There are no intersections. And that's a great starting point for the next Vellum sum we're going to run. But that being said, I still want to show you the Vellum rest blend thing. So Vellum rest blend, typically, so if you go inside, what it allows you to do is, if let's say I have, you know, this flower here this is like my my normal flower. God, stop calculating. Turn that off. So if I have this is my normal flower, and then I could also create a second one over here, and let's just put like a mountain on it and just give it a bunch of noise. So this could be like the guide that I want it to get to. So basically with a Vellum rest blend, in here, I could take this here and blend it with my originals over time. That's cool. So like if you want to have like, you know, some of the examples I've seen online are like turning a cube into a sphere over time, but in Vellum. So it, like, you know, really organically morphs into a cube. That's great. So using this as a guide is nice, but I also discovered that you can actually blend to itself. So instead of creating a second piece of geometry that we're trying to get to, I can just have it try to blend to this cloth start. So let me show you that. So if I come in here, I want to change this to each frame, And then instead of simulation geometry, I want to change it to SOP. And then I want to find my cloth start. So there's this blend value here. A value of 0 does nothing. That just means that the sim is going to go. Oops, let me re-enable and clear the cache. So if the sim is just going to go as planned, nothing's going to happen. There's no blending. But if I change it to a value of 1, it's going to immediately try to blend to whatever this SOP is. And I could give it anything as long as it has the same point count and it's the same. It's the same. So right now I'm just going to put it to 1. So what's going to do is it's going to try and blend to this thing, which is constantly animating. So hopefully that makes sense. I don't know if I'm explaining it well, but I was really excited to find that you can blend a shape to itself instead of a separate guide object, and it works really, really, really well, especially for those like shrinking pieces. So that's pretty cool. It's pulling it a little too fast, so I want to maybe put some pop drag in there so that it kind of comes to a stop. So this is the de-intersect process. This is the thing that I was really missing when I originally made my flower animation. I couldn't figure out how to get stuff to de-intersect. So let's find a nice frame, maybe there. So that looks good. So frame 89, okay? And so let's put a time shift. And let's just delete this. So now I can scrub back and forth, and I have my starting point for my flower. Pretty nice, right? Okay, so let's put this in a net box. We'll call this de-intersect. And make that, I don't know, purple or something. Okay, so we've got this thing time shifted here, and it's frozen. This is kind of our nice starting point. And from this point forward, we can now animate it closing, and then we're going to run it through another Vellum simulation so that it doesn't intersect. But before that, something that's really cool that you can do, I don't know that this one necessarily needs it. It's a pretty simple flower, but something I was doing in my research over the last couple weeks was using the Vellum brush, which is pretty cool. So let's actually time shift away. Let's time shift the constraints as well. If I go Vellum brush, this is something I hadn't really used before, but it is super cool. When you have more complicated flowers, and let's turn off our visualization here. So like I said, this is a simple flower, but if you have something like a rose or something with like a ton of petals and you want them to be really crinkly and wrinkled looking or be very specific, this is a great way to kind of get it into that position. So what the Vellum brush does is you can use this to sort of brush things into the position you want. And I don't know why this is showing me two things. Gosh, sometimes the viewer, let's go scene view. Yeah, there we go. Sometimes you just have to refresh the viewport. Houdini 19. So, but it gives you these nice brushes here. So here I can change it from screen. I like volume. Hit enter on the keyboard. And this allows me to, so the mode is brush, and that basically you can move things in the direction that you're brushing. It's cool, right? Or you can use drag. I like drag as well. You can just literally just drag things into position and it won't collide. It's basically simulating the cloth as you're brushing. Really, really cool. So it allows you to have really direct control over what your fully bloomed flower shape looks like. So for right now, I'm just showing you how this works. I'm probably going to delete this node here in a sec and not use it. I would use this on something, like I said, more complex, like a flower, like a rose. But you can also use like crease and ruffle, which is nice. Kind of gives you these creases here. And if I hold Control and do it, it does the opposite. So you can either crease or you can ruffle. So you can kind of dynamically put in some wrinkles. Or you can do contract, expand. So if you hold Control, it does one. If you if you hold the other one, it does the other. So you can put creases in. Rotate is pretty nice. You can just kind of like rotate the whole thing. And then you have different shapes too. You have brush, you have surface. Connected geometry is kind of nice. It just takes each piece and just does whatever you just to that piece. So if I want to like reposition something, like I like everything, let's say, okay, so maybe this one here, it's a little too far away. I can do connected geometry with a mode drag and just kind of drag the whole thing closer. And it respects the collisions. And see how, look at that. It's amazing. So it's a really great way to have very granular control over the art direction of what your flower looks like. But for now, I'm not going to use that. Like I said, this is a very simple flower, and I don't really necessarily need that. I don't need these to be any wrinklier than they are. I think just for the purpose of this demonstration, I'm going to use it like this. So cool. So now what I want to do is I want to put a bend deformer on each one of these and bend them inwards. Instead of doing that with a bunch of different bend deformers, we're going to use a for each loop. And this is really simple. This is another thing I was missing in my original setup, is I had no understanding of for each loops. And so I literally just did this all by hand, which totally sucked. So we're going to use a for each connected piece. And it throws down this connectivity SOP, which adds a class attribute. So if I click on that, you can visualize it. Gotta turn my visualizer on there. So you can see it auto detects, whoa, what have I done? Somehow I got to my channel list. Weird. Okay, so turn off this, turn on class. So it'll color each piece individually, which is really nice also when you're doing a Vellum simulation. It allows you to see collisions a lot easier. So cool. So in this for each loop, I want to put down a bend. And let's just turn on single pass so we can see each of these. And let's highlight this, hit enter, and you can see the bend here. Now it's facing the wrong direction. It's not doing anything. It's not aligning with this properly. And if you go to, if I scroll through these, you're going to see the same is true. So I have to find a way to procedurally get this bend to align in the proper direction and proper length with every single petal. And it's actually not that hard to do. So this is really the only part where we're going to use a little bit of Vex, but it's not complicated. It's very, very simple. So what I want to do is so if we go to the bend, the things that I need are a capture origin, a capture direction, and a capture length, right? So we know the capture origin already. That's the start point, right? So if I just take, if I just go like this, and go blast, and blast off the start, and hit delete non-selected, there it is. That's going to be my start point for every single one, right? And so what I want to do is I can just go edit parameter interface here and just put in, where is it? Add a spare input. And what that does is it puts this extra slot here in the bend parameters, and I can just drag my blast there. Then in my capture origin, I can do a detail function. So detail, and then instead of doing the whole like quote dot dot slash thing that you've probably seen before, you can just put -1. So if you hover over the spare input, it says, oops, you can see it says refer to this in expressions as -1. So instead of having to type in a whole thing, it just spares me that and allows me to just put -1. And then the attribute name that I want is P. I want the position. And then I want it on 0. So now this is a vector though. We need all three parts. So I need the X, Y, and the Z, or the 0, the 1, and the 2. So let's go like this, copy it, paste it here, and change this to 1. Okay, copy this here, and change this to 2. So basically what that's going to do is now the bend should be in the proper position for every single one of these, no matter where they are. I think they probably already were, but just to be safe, that's how you would do it. Okay, the next thing we need is the captured direction. So I need to basically make a line from this point to this point to create the direction. Well, that's why we created the start and end points at the beginning. So what I'm going to do is come back up here. We're going to go blast, and we're going to blast the start and do delete non-selected. We'll call this start. And let's move this crap down so I have some room. Call this start, and then we'll call this one end, and we're going to blast off the end. Okay, so we now have this end point here, you can see, and the start point here. Now what I need to do is merge them together and then put down an add, and we're going to go to polygons by group, and it should just automatically create a line between those 2 points, which it does. So now if you see that, there's a line going from the start to the end. If I go to each one of these now has a line from the start to the end. Perfect. Okay, so that gives us our direction, and it also gives us our length. We just have to learn how to, we just have to kind of extract those attributes. So this is the part where I'm going to use a tiny bit of code. And don't worry, it's not all that scary. I also don't like using code that much. I would much prefer to do things with sliders and buttons, but I couldn't really find a way to do this. But I think this was just the simplest way. So we're going to call this dir and len. We're going to direction and length. So the first thing we want to do is we want to get our direction here. So what I want to do is create a normal that points from this point to this point. That will be our direction. So let's go v at n equals, and we're going to go point 0, because I want to if I go turn on this, oops, this is point 0 here. That's what I want. Point 0, and I want it to get its position, and then I want to go like this, and then I want to subtract it from point 0 p. I suppose I could have just copied and pasted this and go like that. Okay, so what I'm doing here, in order to create a line between that points to another point, you have to subtract them. So what I'm doing is I'm taking the position of this guy right here, and I'm subtracting the position of this guy here, and that will give me a line that points between the two. Okay, and so what I can do, I can visualize that now. If I hit this, pretty cool, right? So basically that's what this point function does. It basically gives, I can pull out any attribute. So from point number 1, which is this one here, I'm pulling out its position, and then from point 0, I'm also pulling out its position, and I'm just subtracting the two, and it gives me a line between the two. And if I hit D on the keyboard and go to guides, normals have been scaled down to 20% automatically. If I scale this up to 1, you can see it gives me the exact length. So this one that's starting at 0, it's also the same length as the line. So not only does it give me direction, it gives me the length, which is exactly what I need to feed the bend deformer. So I just need to write this out to a different attribute, or I guess I don't need to, but I like to. Keeps it cleaner. So v at dir for direction equals at n. Cool. Now I should have dir. There it is. Okay. Now for length, all I need to do is take this vector that's pointing from 0 to 1 and measure how long it is. And you can do that. So we'll go v, we'll create an attribute called v at len. Oops, len. And there's a function called length, which just measures the length of whatever you put in between the parentheses. And I'm just going to measure the length of at n. Okay, so now I should have a point attribute called, if I come down here, len, right here. And it should be the same number for all three. Cool. So the length of this is 0.781. That seems right. Okay, cool. So I've got direction and length. Now all I need to do is transfer that. See, because I only have it on these 2 points. I need to transfer it back to my actual petal. So let's go attribute transfer. Plug that in here. And then I want to stop visualizing all this crap. I want to go dir and len. So now I should have direction and length back on my petal. Cool. Okay. Easy enough. So now we're back to the bend. So let's start with the direction. Basically, we just need to do this exact same function, but instead of a detail function, we know that this is a point attribute that we just created. So let's just copy this. Let's put this here and change the detail to point. And let's go 0. So that's the geometry stream is 0, which is the incoming one. And then I want point 0. Let me just, so you need the surface node, which is the incoming node that you want, which is 0. I want the point number, which is also 0. I want the attribute, and then the index, which is its vector. So let's go 0, and then 0. Then the attribute I want is dir, and then 0. Okay? And then let's copy this, and let's go here. And I want the y position, which is now 1, x, y, z, 1, 2, 3, a, b, c. Okay, and then 2 will be the z position. Okay, so there. Now it automatically aligns. Look at that. It's aligning perfectly. So if I come back and scroll over, now this should be aligning perfectly. Now it's not the right length yet, but now they're all able to bend inwards. So if I turn off single pass and come to bend and just go like that, I can bend them all inwards like that. Pretty cool. But let's get the length just for the sake of doing it, even though it's already pretty good without it. So the length, we already have the length. We just need to put it here. It's just point. And then we want to pull this from, we could pull it from any of our points, but let's just do 0, 0, len, 0. And then that should adjust. There, now it's exactly the size of our petals, right? So if I turn off single pass, and I now can animate the bend, so I'll go start at 0, and then come to like 72, and let's bend this in like that. There we go. Okay. I think I also want to transform them. Let's shrink them a bit. So let's put a transform in here. So as they bend inwards, I want them to shrink. So let's keyframe the uniform scale, and then down to 72. Let's bring it to like 0.7 or maybe 0.6, so that it looks like, so when we reverse this, it'll look like it's growing. Now these are all happening at the same time. We don't want that. We want to time offset them, which is also pretty easy to do. So in order to do that, we need to put down a time shift. And we're going to do a little bit of H script here, I think is what it's called. So what I need to do is come back up to the top part of this thing and use create meta import node. And I'm going to change this to info because it's just easier to type instead of that whole thing. And if I hover over this, the detail attribute that comes with it that I'm looking for is iteration. So basically, there are 13 iterations, 13 pieces here. And I want to offset the time of each of them by the piece number. So the way I'm going to do that is I'm going to go $F minus detail, and then quotes .. I could have just done the spare import thing like I showed you before, but this is fine. End quotes, and then again in quotes, the parameter I'm looking for is iteration, or the attribute I'm looking for, and then 0. Okay, so basically this will be it's saying take the current frame number and subtract the iteration number from it. So now this should offset a little bit. So you see now instead of happening all at once, it's happening from the outside in. Now that's cool, but I want it to happen from the inside out. So in order to do that, let's multiply this times -1. And now it happens from the inside out. Now in order to, you can have a little more control over this, you can offset these even more. So instead of -1, I could do like -2. So now there's more space in between, more time in between when each petal bends inward. So let's if I go like -6, something like that. But you see, it kind of starts. It's starting like already collapsed a little bit. So I'm just going to add in +12 or something like that, and then I can take this number and I can just scroll. Another handy trick is if you hover over the number and just scroll like that, you can with the middle mouse you can actually just change that number without having to type it in. So I'm just going to kind of scroll left until I see something like that works, right? So $6 - 70, and then that'll give me, see how there's a lot more time in between each of these. Now I think that's probably too much time. I was just showing you how to do that. I'm probably going to go like -1.2, and then instead of subtracting 70, let's just, let's do like I don't know, 10. Does that work? Let's see. Let's scroll around until we find something. So maybe there is good. Cool. Yeah, 10's fine. Cool. So that gives me what I want. So they're all animating correctly, and they're intersecting, which is not what we want. So we've got our animated flower. So let's just put a null out animated flower. Cool. Save that. Okay, and then we're going to run it through our final Vellum sim here. So again, just Vellum cloth, Vellum cloth, and then we need Vellum solver. We're basically going to do the same thing we did before. So again, let's call this start animate, start anim, sure. And I want to pin the start points again, and let's just do permanent, that's fine. Or let's do soft and match animation, yeah, okay. Okay, and then for this, I think, let's see what I want to do. So this one here allows me to adjust the feel of the cloth, so how stretchy it is. So maybe I'll do, right now it's not very stretchy at all, so maybe something like 1 × 1,000,000, and maybe I'll increase the damping ratio again, something like that, and I don't know, bring this way down, the bend stiffness way down. Usually if you bring the bend stiffness way down and the stretch stiffness way down, you'll get really like thin, wrinkly looking stuff, which is kind of what I want. So we'll see how that works. And then again, we need a pin constraints, just like we had before. So Vellum pin, Vellum constraints, and let's just wire that in there. And then change this to pin to target. And again, we want to pin the points and just hit everything. And again, soft and match animation, right? Okay. And let's see, let's do the same as we had before, which was, I think, 1 × 0.001. I like to increase the damping ratio a little bit just to kind of pull out some of that energy, make it less jittery. And then 1 × 0.001. Maybe let's do 2 zeros, something like that. Okay, and let's just see what that looks like. Woo! Forgot to turn off gravity. Let's see what that looks like. So it's working, but it's getting all crinkly. See how these are getting all like folded and stuff like that? That's because we're shrinking it. So remember how I said before, when you have, I put this transform here, I'm shrinking everything, And it's hard for Vellum to calculate the constraints properly when you're shrinking something like that, because the constraints are telling it to retain its original size, and we're not changing the constraints at all. So we're like forcing the geometry to get smaller, even though the constraints are saying keep your original size, and it ends up with this like shitty looking crinkly piece of crap. So that is the whole reason that we're going to use this Vellum Rest blend again. Vellum Rest blend. And I want to, again, do each frame. And instead of simulation geometry, let's use SOP. And we'll come up to, what is it? Start anim, that's the one we just made. And then instead of blending over time, or, remember, a value of 0 means nothing happens. It's just going to be the original simulation. A value of 1 means immediately blend into this SOP. So I found somewhere in between worked pretty well. So like 0.675, just leave it there. And then again, let's put some drag. Just kind of helps a little bit. And let's see what that does. So it hopefully will give us a little bit better of a simulation where it's not getting super wrinkly as it gets smaller. So the nice thing about the Vellum Rest blend is that it updates all of the constraints for you, which is really nice because I'm not super great at constraints and stuff yet and figuring out which ones I need to update. So this just does it all for you, and I'm just blending into that shape. Pretty nice, right? So I've got what I want, and now all I need to do is cache it out, and then I can just time reverse it, and there's my sim, right? Pretty nice. Cool. And then again, it's all procedural, so I could come back up here and I could change the shape of my petal. I can give it way more noise. I can make 200 petals. I can use my MOPs transform fall off to kind of angle things upwards or downwards or whatever. Or I could do the Vellum brush in between or right after the de-intersect to like brush it into the exact shape I want. But now I just have this nice looking animation. Pretty cool, right? So hopefully this helps you guys. I may make later on a more complex one that shows how to make like more complex flowers. There's a few other things that I could do. Like right now I have a bend deformer in there that's just simply bending it towards the center. But in some of my experiments, I had a few different bend deformers. I had one that's kind of curling it inwards from the side and making the ends sort of roll up, which is all fairly simple to do if you understand, if you're able to understand this basic direction and length thing. So I may make one later showing how to do that, but this tutorial is already running fairly long, and I don't want it to be a 2-hour tutorial. So I hope this helps. But in terms of like rendering stuff, I'm not going to go super into detail on that, but we still have all these attributes that we can use. We have, if we come over here and I want to make a mask, so I can use mask on each one of these. I can bring in mask in Redshift and color the tips differently from the center. I could use where's middle mask again, and I can adjust these things and use that in Redshift to shade and light it, or to shade it. And then of course I have my UVs still. So if I find a nice texture of a flower or something like that I want to put on there, it'll map properly and it'll bend according to my animation. Cool. So I hope this helps. As always, let me know if you guys have any questions. Leave it in the comments. I hope that I was able to take something that I found very complex and turn it into a simple thing that's fairly easy to understand. I wouldn't say this is a beginner tutorial. It's definitely still kind of intermediate. You have to have a little bit of understanding of Vex, but from what I've seen, it's way, way, way simpler than a lot of the other tutorials out there, which is just like paragraphs of Vex and kin effects and things that I don't really understand yet. Maybe I will someday, but there you go. All right, thanks.